episode of Global Education Zone, and this is the channel where we give you every video you need to know on education and any subject you want in your secondary school or your high school. So now, and today in this video, I'm talking about geography, and in geography, we'll be talking specifically about the topic known as the earth structure and rocks. So I'll be talking about the earth structure and rocks, and without wasting much time, let's delve into the matter. So now, earth structure, we live in the earth, right? And the earth is made up of different structural units. And these structural units, they are basically four physical structural units. And these structural units, they are known as spheres. Now, a sphere is basically just like a spherical object, right? Now, this earth is a geoid, and this geoid has its spheres of life. And these spheres of life are basically we have the lithosphere, LITHOSPHERE. Then we have the hydrosphere, HYDROSPHERE. Then we have the atmosphere, ATMOSPHERE. Then we have the finally we have the biosphere. These four spheres I've listed so far, they might not be the only spheres, but they are the major spheres we'll be dealing with in this video. So now let's talk about the lithosphere. The lithosphere, just as its name states, lithos, is basically talking about the soil and the crust. So the lithosphere is basically the solid portion of the Earth's surface. Then this lithosphere, it is basically the ground, the earth, the soil, those clay sand, sandy soil, humus, and so on and so forth. So that's lithosphere. It is the part that supports every other structure. For example, the lithosphere supports the oceans and even the land surface. So the lithosphere is basically when you dig deep into the soil, it is kilometers deep into the soil. And the lithosphere consists of different subparts. And the lithosphere is divided into the crust, the mantle, and then the core. Now the crust of the earth is the first part of the lithosphere, and it's spelled CRUST. Now the crust is the uppermost part of the earth's surface. That crust basically consists of an upper part and a lower part. So this lithosphere we're talking about consists of the crust, the mantle, and the core, and that crust consists of the upper crust and the lower crust. And the upper crust is basically made up of silicon and aluminium. So those are the major elements that make up the crust. And just for saying, this silicon we're talking about here, it is the major elements that makes up the Earth's crust. So, and it is the second most abundant element in the Earth. So, and it is also very, very instrumental in integrated circuits manufacturing and in computers. So, and then moving on, that was just by the way. The lower part of the crust is made up of three elements: silicon, iron, and magnesium, and that's called CIMA. So that's the lower part of the crust. And when we dig below, that is like in the order of 10 to 40 kilometers below the Earth's surface, or below the lithosphere. Then we'll go on to the mesosphere, and that mesosphere is also known as the mantle. Now I'll draw a diagram of the Earth. Then this Earth we're talking about here, I said earlier that the Earth is a geoid, right? So it's kind of circular in shape. So, and then the first part of the Earth you encounter is the lithosphere. Then before that you get to this is the lithosphere. It is like the body of solid matter. Then we also have the core. So the core is at the center of the Earth. Then outside the core, we have the core is surrounded by the mantle. So this is the mantle. Then this is the core. So this core of the Earth we're talking about is as hot as 6,000 degrees Celsius. This is the core, very hot. And recently, some scientists are thinking of have been doing steps to extract energy, or also known as geothermal energy, from the core. So that core is the center of the Earth because of this high heat, and it's the cause of most volcanic eruptions. Then we have the mantle. Outside the core is surrounded by the mantle, and the mantle is also known as the mesosphere. Then outside the mesosphere, we have the lithosphere. So now this solid part of the Earth, below the lithosphere, we have the crust, and that crust is also known as the lithosphere. in essence. The crust is the lithosphere. Then below the crust or the lithosphere, we have the mesosphere. That mesosphere consists of basically basaltic rocks, and it's at a very high temperature. Lithosphere consists of basaltic rock at a very high temperature, and majorly the mesosphere. Sorry, the mesosphere is in a semi-liquid form, and it consists of olivine. Olivine is a particular type of element in the mesosphere. So then after the mesosphere or the mantle, we will go down into the core. So that core, it is the center of the earth, also known as center of the earth, and then that core consists of majorly two elements, which are nickel and iron, also known as knife, NIFE, knife. So now that core, as I said earlier, is at a very hot temperature, and it is the last stage of the earth that you will get to. So after the lithosphere, we have the hydrosphere. The hydrosphere is the watery part of the earth, and the hydrosphere consists of 70% of the earth's surface area, and the remaining 30% is covered by the biosphere, or rather the lithosphere. So after the hydrosphere, we have the atmosphere. The atmosphere is the gases, the layer of gases above the earth, and then that atmosphere is divided into the ionosphere, the stratosphere, and the troposphere in order of decreasing height. Now the ionosphere is farthest away from us. The stratosphere is farther, then the troposphere is far. So they are all far. They are in the order of several hundred kilometers away from the Earth's surface. Then, well, after the atmosphere, we have the biosphere. The biosphere, it is not basically any corporeal part of the Earth. It is not basically a very tangible part. It consists of all the living organisms, and those living organisms, the reason why I said the biosphere is not tangible is that those living organisms, they can include the atoms, just like your amoeba. Amoeba is also part of the biosphere, and then the biosphere is basically the living part of the earth. So those are the plants, animals, and all the rest. So those make up the biosphere, and that biosphere also includes the environment where those animals, those living organisms live. So in the biosphere, they live inside the lithosphere, and then the biosphere is specifically a very thin layer of the lithosphere, like the topmost part of the lithosphere, where your plants grow, where we build our houses, where the birds nest in the trees. Those are all biospheres. Then those are the four major spheres of the earth. Then which are the then let's talk about the rocks. So rocks, we have different types of rocks. We have igneous rocks, sedimentary rocks, and metamorphic rocks. But what is a rock? A rock is basically a material that is the parent material of our soil. So the rock is the parent material of the soil, and the rock, they are mostly formed by the volcanic eruptions. Just like the when you have your internal activity in the earth's crust. So and that internal activity will result in high pressure in the earth, because when the metals and the substances in the earth's crust, when they liquefy, they actually cover a lot of volume, because when you increase the temperature of a substance, you are actually increasing its volume. So and then when your volume increases, the pressure increases. So in that is if the area is consistent, because that your volume and your pressure, they have to be the same. So that those volume, they kind of those matter in the earth's crust, under the earth, they actually push this they are pushing out from the core, because it is very hot in the core, so they are pushing out, they are looking for space. So and then if they find any weakness in the mantle and the lithosphere, they will exploit that, and then they escape through the surface of the earth. So and that results in what is known as igneous rocks. IGNEOUS. Igneous rocks are rocks that are formed by the volcanic eruptions, by the process I described above before. We have igneous rocks. They are often very strong. They are crystalline rocks. They are very strong, and they are resistant to corrosion. They are non-stratified, and they don't consume fossils. So they are basically found when molten lava from the earth's crust is ejected through the surface of the earth, and then and when it gets close, it forms magma, which cools and solidifies. And then we have two different types of igneous rocks. We have plutonic or intrusive igneous rocks. Then we have the volcanic or extrusive igneous rocks. And basically this simply means that when you have a plutonic igneous rocks, those rocks, they do not solidify at the surface of the earth. So they solidify before getting to the surface, and that is because of the fact that this is either those gases, those liquids, those substances, they are not coming to the earth at a high enough pressure to penetrate the layer of the lithosphere, or it's either that they are at a much lower pressure than necessary. So when those gases, they almost get to the surface and they solidify before the surface, it's called plutonic igneous rocks. Then when they solidify after getting to the surface, they are called volcanic igneous rocks. And those volcanic igneous rocks, they are mostly the rocks you see, just like Mount Kilimanjaro, Mount Fuji, and all the rest. So all those mountains, they are often made up of volcanic igneous rocks. And you also notice that they are often very, very hard. Then after igneous rocks, we have sedimentary rocks. Sedimentary rocks are basically rocks that are formed when different materials are formed together, different materials clump together. So, and those sediments, when they gather together and solidify together, they form a rock known as sedimentary rocks. And those sedimentary rocks, they might not be hard. Some of them are in the form of liquids. For example, our petroleum is a sedimentary rock because it is formed from when it's found. Petroleum is found in sedimentary rocks, which are formed when the sediments of matter of different liquids, gases, and solids, they press together carbon. So, and that carbon, it undergoes some processes which turn it into petroleum and other substances like gases. So, and then those sedimentary rocks, they are often stratified in that they have layers. For example, in 1000 years, a particular layer will be formed. In 2000 years, another layer is formed on top of that previous layer, and so on and so forth. It's just like a cumulative effect. So, and then those rocks, they are often containing fossils, and they are not very strong. They are not strong, and they are not as strong as igneous rocks. And those rocks, they are often sandy, and so on and so forth. So, you can, if you cut a section through those rocks, you will see if you cut those sections, if you cut those rocks through, just like most geographers do when they are searching for fossils, when they cut through those rocks, they see layers of different colors of layers. So we have the topmost layer, different colors from the middle layer. It's just like a layer, a wedding cake that has different colors. Like just like when you place chocolate cake on velvet cake and then on milk cake and so on and so forth. When you cut through those cakes, they have different colors. That is how sedimentary rocks are. So I was just using that as an example. Don't mistake those. That's cakes and rocks are different. So then we have after sedimentary rocks, we have metamorphic rocks, and those metamorphic rocks, they are also known as the rocks that are changed by erosional and depositional processes. So and then those rocks, they are formed when igneous rocks, they are over the years. Igneous rocks are weighed away by forces of erosion, and forces of erosion include your wind, your water, your glaciers, which is your frozen water or your ice. Then those glaciers, they are often having a very, very strong power of erosion by freezing and thawing the rocks. So that was just by the way. Then if you want to know more about those glaciers, there's a video on that. I've talked about the Earth's processes and erosional processes. Then also these forces we're talking about here, they basically weigh away the rocks and the igneous rocks. So when they weigh away them, they form what is called metamorphic rocks. And these metamorphic rocks, they are also known as change rocks. And they may be crystalline or not, they may contain fossils or not, and they may also be stratified or not. So that's majorly for rocks. And then now let's talk about the importance of rocks. Now rocks are important for different reasons. Rocks are sources of minerals. For example, like our gold, diamond, limestone, in limestone caves and all these regions. So then we have petroleum. Petroleum are formed from within our sedimentary rocks. Then we have rocks as sources of fuel. So like petroleum and coal, they are from our rocks. Then we have chemicals too. We have chemicals from rocks. Just like when you have rock, when you break those rocks down, you have chemicals from them, such as sodium and even our metals. So we have construction. You use your rocks for constructing roads and all the rest. We have tourist centers. For example, in Nigeria, where we have what is known as Olumo Rock, and that Olumo Rock is located in Ogun State, and then it is a famous tourist attraction. Then we also have rocks are used as ornaments; they decorate, and then we have sources of food nutrients. So rocks contain salts, all these salts, and for example, we have a particular salt which is edible to man, which is called sodium chloride, and then that salt is often consumed, and they are gotten from rocks. So formation of soil, sources of metals, domestic uses, and raw materials for industrial processes. So, and those are the major processes, those are the major advantages of rocks. So, in summary, what I've been talking about so far, what I've been blabbing so far. So those, we've talked about the earth structure, and we've said the earth is consisting of the lithosphere, and the solid part of the earth actually consists of three parts, which is the lithosphere, the outermost part, the mesosphere or the mantle, the middle part, then the core, which is the hottest part of the earth. That's the solid part. Then we have the liquid part of the earth, which is the hydrosphere. Then we also have the gaseous part, which is the atmosphere. Then we have the living part, which is the biosphere. So, and then I'll talk about the also the rocks, which are igneous rocks, metamorphic rocks, and sedimentary rocks. I'll talk about the importance of